Hello again, math students. Today we're going to be starting what's called the Pythagorean Theorem. It's developed by this guy named Pythagoras. He was kind of a big deal. And he found this relationship in the sides of right triangles. And it only works for right triangles. But we can find a missing side length if we know two of the other sides. And again, this only works for right triangles, so we have to be careful about that. So again, a right triangle just means that it has a right angle. The two sides that make the right angle, those are called the legs. Okay, those are the two sides. This is labeled on here in this picture as A and B. I don't want to start drawing all over the picture, but those are the legs. The other side, so we've got an A and a B, the other side is called the C. That's the hypotenuse. In a right triangle, the hypotenuse is always the longest side. It's always across from the right angle. Now, the right angle is also going to be the biggest angle in a right triangle. I can't have anything that's bigger than that. So across from that is going to be the hypotenuse. When we're solving the problems today, it's going to be really important to notice if we're looking for one of the legs, the A or the B, or if we're looking for the hypotenuse, which is the C. And again, that's going to be the longest side. In the Pythagorean theorem, this is what we're going to be using. That is the Pythagorean theorem. A squared plus B squared equals C squared. That means that if I take the length of each of the legs, the sides that make the right angle, and square each of them and then add them together, that will give me the same length as the hypotenuse squared. The reason we're doing this in this chapter is because we are going to be solving some equations. We'll be using square roots to do that. Now, you might be able to see there is a little video that I've got linked right there. I'll probably try to link that in the folder because it won't show if I just try to do it during my video. But I will put that in there so you can kind of see how the Pythagorean theorem works. This is what we're going to be taking a look at today. We've got a picture of a right triangle here. And because you can even see that they labeled the hypotenuse as C, or C is always going to be the hypotenuse, the other two sides are the A and the B. I don't care which one's which. It really, truly does not matter if the 5 is the A or the B, if the 12 is the A or the B. But I'm going to put those two numbers in to the Pythagorean theorem. So there's my A squared plus B squared equals C squared. I'm going to put the A in as a 5 and the B in as a 12. Now that we've memorized a bunch of these numbers, it will save us some time on some of these. 5 squared is 25 and 12 squared is 144. And again, just simplifying or just solving this equation, I could add those two together and I get 169 equals C squared. 169 is a perfect square. I can take the square root on both sides and I'm going to get a nice answer. Notice it does say here, only take the positive square root. Remember, I'm looking for a length. I'm not going to get a length that's negative. However, when we were solving equations, I made a big deal about saying, if you draw in the square root, you put in a plus or minus. In this situation, the negative answer just doesn't really make sense. So when I do that, when I take that square root, I get that this is 13. So that means that this hypotenuse would be 13 meters. The hypotenuse is always going to be the biggest number because it's the longest side, because it's across from the biggest angle. So if you would get an answer here that was smaller than 12, for instance, you must have done something wrong. The hypotenuse has to be the biggest number. In this first example in this slide, again, I've got the two sides that make the right angle. That means that the 8 and the 15 are the A and the B. So when I'm doing this, you may want to start by writing A squared plus B squared equals C squared. It doesn't matter which one of these are which. I tend to put the smaller number as the A just because that's just what I do. But the way that this is lined up, I'll say that this A is 15. That's going to get squared. The B is 8, and that'll get squared, and that'll be equal to C squared. 15 squared is 225. 8 squared is going to be 64. Now, in case you haven't realized this yet, you are really going to want to have a calculator handy today. Not only just for this like adding and subtracting, but also for taking square roots. And if you need help with remembering how to get square roots, I can help you with that. So 289 is equal to c squared. Now 289 happens to be a perfect square. If I take the square root of both sides, and again, remember, I'm not going to worry about the plus or minus when we're working with lengths, but the square root of 289 is 17. Now, something that I find interesting, but maybe not everybody does, is there are numbers called Pythagorean triples. This happens to be a Pythagorean triple because when I find the missing side length, all of these are nice whole number kind of answers. So 8, 15, 17, or any multiple of that. If I would multiply everything by 2 or by 3 or by 10, those would all work. In example 2, I've got fractions, and again, I know that some people might worry about that a little bit, but this is not a big deal. I would also not change these into decimals. I know you certainly could, but I would have 3/10 squared plus 2/5 squared equals c squared. And again, if you had changed this into a decimal, this would be a 0.3. 2/5 is really a 0.4. Right, so if you'd rather have those decimals, you can certainly do that. This would be 9/100, and then this would be 4/25. Well, I could get a common denominator. Denominator is going to be 100. 25 times 4 would give me 100, so then 4 times 4 is going to be 16. And when I add those, I'm going to get 25/100, and I kind of ran out of space there, so I'm going to put it up here. 25/100 equals c squared. So square root of both sides. Now that does simplify, remember, but they're also perfect squares. So the square root of 25 is 5, the square root of 100 is 10. That would be 1/2 for c. And this would be in inches. If you had used decimals, you just would have gotten 0.5 instead of 1/2. For the next one, still trying to get the c. All of these examples so far, we've been looking for the c. The second one on this slide is not going to be the c. But I kept this one because we've got some decimals in here now. This is where we really do want to have a calculator handy. So the two sides that are given to us, again, are the a and the b. So I would have 3.6 squared plus 4.8 squared equals c squared. 3.6 squared is 12.96. 4.8 squared is 23.04. And then I would add those two together, which gives me exactly 36. And then I would take the square root of each side. So my c is going to be equal to 6 meters. So those are lengths. In the second example, I don't have a measurement on there to say if I'm measuring in what kind of units. So the new problem here is that I'm not looking for the c. I know the c. The 9 has to be the c because it's the longest side. It's across from the right angle. The 4 can either be the a or the b, and then the missing side can be the a or the b. Personally, I tend to make my missing side a just because I like how the equation looks better that way. Then the b would be 4. So I would say a squared plus 4 squared, because that's the b, equals, instead of c squared, I'm going to say 9 squared. 4 squared is just going to be 16. I don't know what I'm writing here. 9 squared is 81. And you guys are good at solving equations now. 81, I'm going to have to subtract the 16 from both sides, and that's going to give me that a squared equals 65. Not a perfect square. Not a number that we have memorized, not like this last one where it's 36. When I take the square root, I'm going to get a decimal. So the square root of 65 is, on my calculator, 8.06225, blah, blah, blah. It's going to keep on going. We're going to be rounding to the nearest tenth. one decimal place. So this will be 8.1 as my answer. If we were in class face-to-face, I would be asking the entire class, am I looking for an A or B, or am I looking for the C in this problem? And in this problem, it's going to be very similar numbers to the last one that we just did. I'm looking for either the A or the B. I'm given the C is 9. So I would have, let's call this one A again. Here's my B, and then this is going to be my C. So A squared plus 5 squared equals 9 squared. 25 and 81. So when I subtract my 25, 81 minus 25 is 56, also not a perfect square. We are most of the time not going to get really nice answers here. This is going to be a decimal. We're going to have to round it, and the square root of 56 is, as a decimal, 7.483, blah, blah, blah. That would round to be 7.5. In this problem, I think that students get tricked on this kind of a picture. The missing side is the C. We're not used to seeing it laying down with the hypotenuse as like the bottom of our triangle. So this is the C again. Now, that means that the 10.9 and the 4, I don't care which one's which. If this one's the A and then this one's the B, it really doesn't matter, or I could flip-flop those. So I would have 10.9 squared plus 4 squared equals C squared. 10.9 squared, I don't have that one in my brain. That is 118.81. 4 squared is going to be 16. So just simplifying, I would have 134.81 equals C squared. And then I don't want C squared, I just want C. So I'm going to take the square root. So the square root of that answer is 11.6107. It's going to keep on going. That would round to be 11.6. And for this last problem, again, just throwing in some decimals, I am looking for the C again. So this is going to be the C. That means that these other two numbers could be the A or the B. It really doesn't matter. We'll just make this one A and this one B. So I would have 4.1 squared plus 6.9 squared equals C squared. 4.1 squared is 16.81. 6.9 squared is 47.61. And then we're going to add those two to simplify. Gives me 64.42. And then I don't want C squared, I just want C. So we'll take the square root of that answer, which would be 8.026. Now I kept this problem in particular because 64 is a perfect square. 64.42, not a perfect square. However, when I round this to the nearest tenth, what I'm going to get is 8.0, right? And we've talked about this. I kept the 8 looking like this in the picture because that's how I had the answer key written, but you guys know that I like to see that 0.0 to show that I really did round to one decimal place. So today's worksheet is rather short, but I do want you to be showing work on your paper. Use a calculator, absolutely, but show what you're doing on your calculator, just like I did. Check it with the answer key and Schoology, and then when you're all done, take the learning check. Good luck.